Okay, so we're recording now. We got everyone's pictures, we got the screen up, we got record. All right. So first off, let me say thank you guys for being so great about last Thursday. I really tried to start Thursday out and the migraine just derailed every plan I had for Thursday and some of Friday too. And then I've been working with Amanda, since then to get ready for her defense tomorrow. So thank you. I hope that you found class time beneficial. On Thursday, the conversations you guys were able to have, the points you brought up, the discussion board, as always, was phenomenal. I have my little sticky note with at least 3 items from the discussion board I want to go over. And just so that you know that it's coming, we're going to go over decisions and reasons for treating time as if it's equally spaced or unequally spaced when the measurement observations were not, in fact, equally spaced. There was questioning in the homework assignment whether your grouping in the formula should use the ID variable or the group variable. So we're going to go over not just what's right, but why, and use of long versus wide format. And we're also going to do a little bit of model comparison, decision making, and the treatment of time. So hopefully all your questions about homework 5 that we're working on will be wrapped up today. I am in the hour and a half before class working on updating homework 6 to go out tonight. So it will pick up where 5 left off. So 5, you had to make a determination of how you're going to treat time, linear, quadratic, wide, long, all those decisions. So we'll go over those decisions today so that you're ready to go into the next part of homework 6. So I've updated the encyclopedia with more not more examples, but more thoroughly fleshed out, updated the examples that are on the encyclopedia about repeated measures or longitudinal design. We're going to look at those today with the remainder of our class. So we're going to start off with the homework. Before we even get to that, my other notes. So 1, 2, 3, 4, 5, 6, 7 of you have already met with me about your course projects, but 7 of you have not. So that needs to happen. If I come over about your, let's see, if I go to syllabus, it should list everything chronologically. So we are on October 13th. It's an unlucky day. So today due is your homework 5, the discussion board about it and actually turning in the assignment. The discussion board was supposed to be done by 4, both your original post and your comment, but the homework assignment is not due till 8 tonight. So based on what we talk about today in class, you can update and resubmit or submit for the first time. Today is supposed to be the due date at 5 o'clock to have met with me about your course project. I know that there were 2 or 3 people that emailed me that I have not gotten back on. A couple people have them booked. If you don't have something booked with me for the next 2 days, you need to get in touch with me ASAP, because I don't want you, the reason for having this course project consultation earlier on is so that you're not scrambling at the end of the semester trying to come up with a project and get it done. I don't want anyone to kill themselves. So it's not that you're going to be docked points, but I don't want you to let this go too late and be, trying to sprint.
Sorry, I have a question about that.
Yeah.
So the course project thing that says it's due today, it looks like it's in the structure on the LMS. It looks like it's in the structure of a quiz.
It is in the structure. So you're supposed to meet with me on Zoom, and then there's this quiz format to fill out. You can fill this out even before you meet with me, or you can wait till after, either way. But this quiz format asks you about what's the source of your data, what's your timeline, or have you already wrangled the data? Do you have to wait to access it? How many levels, what are the units? These questions about, is it clustered? Is it longitudinal? What kind of project it is? So let's see, 5 of the 7 people who've met with me have already filled this out. 1 person who has not met with me has filled this out. But if you have not filled this out, please get that filled out and either book an appointment with me or email me about getting another time that we can meet together, because I know that I'm booked out for most of this week and into next week already.
My question was, will that quiz shut down tonight, and do you prefer that we do that before or after we meet with you? For example, I have a meeting with you on Thursday. Should I wait until I meet with you and then do this?
That's a
Or
good
other way
question.
around?
Let me look here. I want to edit. It does not have an availability shutdown. So this will still be there after tonight at 5 o'clock. It's not going to go anywhere. It will show up as like late in the grade book, but I won't penalize you on it. So it's up to you whether or not you want to fill this out now or wait.
Okay.
Okay. I'm not gonna change this deadline because I want you to know that it needs to happen ASAP, but don't just say, oh, well, it's over. Because that course project is like half your grade in this class. Pretty close. It's a big chunk, a third, something like that. And the reason for the course project is because you need to apply this material to data you care about so that you can digest it and remember it. Okay, I don't want any busy work there, for sure, for sure. Okay. Think so. What was on the syllabus for today was for us to cover the randomized control trials and intervention studies. On this discussion board, which is the next one that's due, it has the reading. Now this reading from Hedeker and Gibbons chapter 6 is more about covariance pattern. It's kind of to get us ready for the next lecture that we're going to have. But there is some material that I've linked here on randomized trials and semi-randomized or quasi experimental designs. This is not covered in the Hawks book for sure, but it's good material that maybe has not been formally covered in your other stats classes. So while we continue to deal with and learn about longitudinal models and rehash that, I'd like you to spend some time at least reading this manuscript on randomized trials and checking out this consort website. I think this article is not super long. This Hedeker and Gibbons chapter is 10 pages. It has lots of figures on it though, so it's not that long of reading. So other than the homework, this is kind of some reading to be going over. So here are some of the key terms and things that come up in these two readings. And I'm sorry, I couldn't find a good video to go with it. So no video this time. I don't know if that's a pro or con. So I have a slideshow to cover some of those ideas. It's in the files for lecture 6 right here, but I'm going to forgo that until Thursday. Today, I want us to really focus on the homework and the encyclopedia longitudinal examples and have those conversations about that material. We'll have this conversation about randomized controlled trials and intervention studies on Thursday. Okay. All right, so let's go into, I'm going to open up my R. Now, I need to make this bigger so you can see that, first of all, I'm guessing. So I'm going to make, in my appearance, zoom in and make a bigger font both. Is this legible on your screens? It's legible on mine. Give me a thumbs down if it's not big enough yet. Okay, so let me know if it needs to be changed. I did want to show you some things there. I put up an announcement that RStudio has put out a new WOW update in the beta version. RStudio, my jaw hit the floor. I'm so excited about this right here. This discussion or announcement. This is an announcement. There's a link to give you a taste, and then there's a preview and how you get it. It's the preview like beta version, but I jumped right on board. If you don't jump on board, it's not going to hurt you, but let me show you what you will be missing. So when you update, to RStudio, right now it looks the same, right? It doesn't look any different yet. But if I go into tools to the global options, and I think it's under code, they have display. Yeah, it takes a while to find it. So under global options, code display, they have this new option called rainbow parentheses. Now, let me show you what it looks like. So if you're doing a code chunk, you ever been doing a code chunk and you're writing something and you start some parentheses and then you accidentally delete it and you start another parentheses and it doesn't run because somehow your parentheses are not matching up? Look, it rainbow colors them, so the outer one, each set is a different color. It's kind of, you know, some people might say blah, it's not important, but I think it's really cool because then you can find out where your parentheses are not matching up a lot quicker. So that's one nice thing. The other nice thing about this version is when you download it, looks the same. You have that option to do the rainbow parentheses, but over here in the corner where we usually have this little button that puts our like outline out for us, there's a new button that kind of looks like the letter A, and it switches to Visual Markdown Editor. This is the new thing. I'm going to click on it. Now look how it changes my RStudio. It looks like how it's going to look when it gets knitted. If I'm going to put a section heading in here, I do a double pound, it knows that it's a heading and it will start making it in a heading. If I put a triple pound space, it knows that it's a third level heading. It starts doing that. Also, you get some buttons up here that look like Word. You get a bold button, an italics, code chunks. You get inserting a link, adding a citation. If your citations are in something like, I don't know, Zotero, whatever's on your computer, you can get your citations right out of it. You can add a picture. You can add a table right here, and you can say, I want 3 rows, 3 columns, and then it makes you a table that you can then start typing into. So this update to RStudio does not add new things for you to learn. It adds new buttons so you don't have to memorize code. So people that were like, I'm not going to bother, don't bother, but you might be tempted. So, and you can toggle back and forth between that new visual view and the old-fashioned standard view. So just bring that up. Okay. Let's us get to the homework. The idea of, let's see, equally spaced versus treating time as unequally spaced. That's not the right one. Where is it? Visualizations. Right there. Task 4. This is the #1 concern on the discussion boards. Okay, so we're going to talk specifically about this homework assignment. In this assignment, they planned to take measurements of the illness severity at baseline 1 week later, and not 2, but 3 weeks after that. It's 2 weeks after that, which would make it week 3, and then 3 weeks after that. So each spacing is slightly longer than the previous gap between observations. Can anyone think of why in the world someone would choose to measure at unequal time points? Like, why didn't they do 0, 2, 4, 6 if they were going to do 4 time points?
I have a guess. Sorry, go ahead, Michael.
Okay, yeah, Jill, you go first, and then we'll have Michael go.
Oh, okay. I would think that they were probably anticipating a greater change at the beginning, and then they were expecting it to be like to be making less of a difference the longer time went. So they didn't feel like they needed to check at the week 2 mark because they weren't expecting there to be as drastic of a change yet.
Michael?
Yeah, I was going to say basically the same thing, kind of like graphing an exponential function on logarithmic paper or something like that. If we weren't expecting the influence to be linear, but have decreasing returns or something like that.
Yeah, so I like how Jill put it. They anticipated that the initial reaction would be stronger. There would be this, and we can look at this picture and see initially in the first week, we see a bigger drop off than we see the weekly drop off after that. Now, as a statistician planning the study, I wouldn't have known that. But the people that are writing this proposal to put together this study have theory and prior research, pilot data perhaps. They understand these phenomenons. Now in education, a lot of times we'll see this, or therapy. Sometimes we'll even see an initial drop off, and then after a time it will plateau flat. And if we monitor long enough, there will be a rebound at the end, which is the purpose of having like that 9-month or 18-month follow-up to see, you know, the intervention helped, but did they rebound afterwards? And so when we expect the changes not to be constant, we would think it would be helpful to have closer observations during the time we expect more change. And when we think things are not going to be happening or changing as much, we can go longer between observations. Now, why didn't they measure these people every week? Can anyone think of a reason why you wouldn't want to measure them every single week?
I mean, there might just be like practical reasons if they have to like, first off, like track down people to like measure them, but also like if they have to compensate them per time they.
Yes. There are a lot of considerations, like a statistician would say, measure them every day for 100 days in a row, but that's not always feasible. And so you want to get more bang for your buck in making an observation because it costs time, it costs money, and the more observations you have, the more likely you'll have attrition if real human people are involved, right? They kind of get, you know, off on other things. So those are all reasons why we might choose to make our measurement occasions not super frequently and not equally spaced, because it's a better use of our resources. And we to put the more observations more closely spaced where we think there's going to be more change, and further apart where we think there's more stability and less change going on. So that would be a reasoning why you'd want to do it that way. So here, this graph plots time by weeks. Now, each week is a week is a week is a week. We can think of this as calendar time, but the number of weeks that are in the gap between observations is an unequal size gap. Now, if we were to analyze this data with a repeated measure or mixed design ANOVA, it would treat those measurement occasions as if they had been equally spaced. And that would treat them as if instead of being weeks, number 0, 1, 3, and 6, if they were occasions in the sequence 0, 1, 2, 3. Now these numbers for OBS are the same size gaps. And so here it is. Oh, I got to run the code. Here it is plotted that way. Now, some people said they feel very, I don't know, squeamish or uncomfortable treating them as equal gaps. And that's okay. The math can be done either way. There are pros and cons to both treatments of timing. Now, this weekly treatment is got the pro that those are how the weeks occurred. But a con to doing it this way is we don't have straight lines occurring. There's not a straight line from A to B, from the very first to the very last observation. There's this like kink or curvature. It's a curve with only this many points, looks like a kink, but it's not one straight line for each group. So if we choose to model time as week, we would have to have not just a linear trend, but also a quadratic trend. Now we can do that, but a model is going to have 2 parameters for time instead of just 1 to accurately match that curvature. If instead we were to model it with occasion number or occasion sequence, now look at the blue solid and the red dashed. These lines are more straight line-ish. They're more linear. So a con to doing it this way is we have to talk about measurement occasions or observation numbers. We can't say the weekly decline. But as long as we're transparent and upfront about that's what we did, the linear growth it's linear in observations, it's not linear in weeks. But the bonus of doing it this way is we can have only 1 parameter for time. We don't have to have obs squared. because there's not much curvature here. Now, we can always compare model fit, but I would say if, for this data set, by looking at the plots, if I'm going to use week number as my time variable, I better have weeks squared also, because visually I can see it's not a straight line. There's at least some kind of kink or curvature or bend to the trajectory. If I model it as observation sequence, I can get away with not having that quadratic trend, but then I will have to be very careful in how I convey the meaning, and I might want to then transfer the plot back to weeks at the end. So there's not a guaranteed right way and there's not a guaranteed wrong way. But the worst thing is to just ignore the question and just do it one way. You don't know and your reader doesn't know. And I will tell you, reading the articles, because I'm still reading them, the articles you guys submitted with, what was it, homework 2? Most of the longitudinal studies, homework 3, most of them did not say that were longitudinal, did not say how they treated time. They didn't say it. So I'm trying to guess. I don't know. That's the worst thing to do, is not be upfront. Okay. Anyone
Comment?
about that? Yeah.
Well, as you've been talking and a little bit before class, I had a thought that may not apply, but that made me feel a little bit better about the idea of using the equally spaced time points, and that was that, like, if I thought about it as more of like a rescaling, like, for example, when we measure earthquakes, the scale we use is like, so earthquakes aren't linear, but we use a scale so that the numbers are normal, and, you know, so that we're not saying some ridiculously weird number for how strong the earthquake is. We can just say the number 8.
Yeah. So earthquakes are, like Michael said, a logarithmic type scale. It's a power of 10 scale. So the difference between a 5 and a 6 is 10 times as strong as a 5, and a 7 is 100 times as strong as a 5 because of the wide range. So we rescale it with the power of 10 scale. So yes, we are only rescaling time. We're not totally burying our head in the sand and pretending like they were equally spaced, but we're rescaling it to be numbers that are equally spaced.
So if I'd like to go off that a little, I mean, I understand that concept. I think in the Hawks chapter, they talk about rescaling children's age by subtracting 6 to everybody. So the base is 6. That to me makes a lot of sense because you're doing the same thing to everybody's time points. But in this case that we're using, it's not like we're minusing 1 from everybody. Some of them we're doing nothing to, like 0, but then the 6th one, we're minusing 3. So it doesn't seem like it's a fair rescaling in a way, you know?
Yeah, this is a good point, Joey. So it is a rescaling, but when you talk about subtracting 6 from everyone's age, that's what we would call a linear rescaling. You're adding or subtracting the same amount to everybody's value. This is not a linear rescaling. It's a non-linear rescaling. And it is okay to do that as long as you're transparent about it and you interpret the results in that vein. Because a rescaling can be linear or non-linear. You just might not have as much practice and exposure to the non-linear version. But you're right, we're not 0 stays 0, 1 stays 1, 3 changes to 2, and 6 changes to 3. They all do something different other than 0 and 1 somehow stay the same, right? So you have to be careful about your interpretation. But it makes the math simpler because now we can do linear change. It's linear change, but it's linear change from observation to observation, not linear change from week to week. Now, there are plenty of studies with repeated observations that choose to repeatedly measure at equal intervals. And in those cases, this is a discussion. It doesn't make sense. If we originally measured them at weeks 0, 2, 4, 6, where the gaps were all the same, recoding it to 0, 1, 2, 3 would be the same thing. It would be like subtracting the same, instead of subtracting the same amount, it would be like dividing the same amount onto each value. We are going to look at another example. So in this case, based on our conversations at this point, looking at the graphs, which one would you prefer and why? Weeks or obs?
Obs,
Because
it's more linear.
it's more straight line and you don't have to worry about doing a quadratic. Now, quadratics are not hard. You just put week and week squared, but the complications comes in if I want to see if it's moderated by group. I have to do group interacting with week and group interacting with week squared. And if I do random slopes, do I do random week and week squared? I mean, it adds a lot more complexity to your model once you start adding random effects and interactions, because anytime you have anything changing over time, you have to interact it with week and week squared. Since when we used weeks, it looks like we have a curve. Yeah. Okay. Every situation's different. So, you know, it goes back to what's the answer? It depends. And to a certain level, it is a subjective choice. And like most things that fall in that category, when you're in that conundrum, you choose what you think is best. And as long as you're transparent and consistently transparent about it, somebody might say, I would have done it differently, but it's not that you're wrong. You are wrong if you do it one way and you don't tell anyone that's the way you did it. And they say, I got a different number. Okay, so these are the two models. This is 6A on the homework, and I don't feel bad going over this with you guys because ideally everyone should get 100% on every homework assignment. This is not, you know, a judgment on your worth. I want you guys to all understand this. So here's the two models as I fit them. So these are both random intercept models. Random intercept because they only have the number 1 in front of that vertical bar inside the parentheses. So this brings up another question that some people had. Do I need to have the ID after the vertical bar or the word group? This showed up, Alejandro. Are you listening? I can't see you, but you asked this one on the discussion board, and I had several people before class log on to ask the same question. So I am going to stop sharing my computer screen, and I am going to share a whiteboard because I want to draw. Oh, where did it put it? Darn it. Oh, there it is. Okay, I got to move your faces. Okay. So in this scenario, we have people. Here's my nice stick figure. And each person is measured 1, 2, 3, 4 times. The lower level is where our outcome, Y, our dependent variable, is equal to their illness severity. And that's the IMPS 79 variable, right? So that is repeated at multiple observations. If we're going to go with the OBS, the independent variable OBS, those would be 0, 1, 2, 3 would be the values at the different observations. So here our level 1 is made up of micro units that are observations. Our level 2 is made up of macro units that are, how do we nest repeated observations? The repeated observations go together because they are made on the same person. So another way we can think about it is a level is made up of a sample. So level 1 is the sample of observations. Level 2 is the sample of people. Now they're not random, We didn't randomly take 4 time points. They were at specific weeks, but they are supposed to be representative of the course over time. And those people were probably at some level a sample of convenience, but they are standing in as representatives of all possible people. That's how we know that how the variable in our data set that shows us people is ID. That's the variable. Observations, the lowest level is always 1 line for each observations in the data set. So the data set always has 1 line for the lowest level units. And then after that vertical bar is the name of the variable that says how those lines should be clustered together on ID. Now, what about group? How many groups do we have here? 2. What are our 2 groups? Intervention and control, or something like that. Is that a random subset of all, or a representative subset of all possible groups? No, that's our full listing of all the groups we are concerned about in this study. So group is not a sample. There are only 2 of them, and those 2 are the full listing that we care about. And because of that, it's a variable that applies to people. Not a level in our model. So yes, we have people in groups, but group is not a level because we don't have a sample of all possible groups or a representative set. We don't have a represented anything. These are the only groups we care about. Are these the only people we care about? No, we want to generalize to all people. Are these all the time points we care about? No, we want to generalize to everything in between them. So the units of observations and people, those are what we want to generalize across. Groups, we don't want to generalize across. We actually want to get a parameter estimate, a beta or a gamma, whatever we're going to call it, that gets a p-value. We want a p-value. We get p-values for variables. The nesting groups, and again, it's the word group, but we mean the nesting units. I guess I should change, well, I'm using the language everyone else uses. We don't want a beta for them. We want to control for variance between them so that we can generalize to all of them. We want to control for person-to-person differences. So we want to control for person-to-person differences so that we can generalize to all similar people. Questions, discussion.
So the group is a level 2 variable, just like gender would be, because it's always going to be
Exactly.
associated with the person.
Yes. Group is a level 2 variable because it pertains to each person, just like sex or age or family history or genetics or any other measurement we could take once on the person. Time, whether we say weeks or observation, that's a level 1 variable because it applies to each measurement occasion. Okay. I'm going to save this. Okay. Stop that share. So let's go back to R. Now I got to share again. And then move your pictures again. Shuffle. Okay. So that's why ID is the variable that we put in the parentheses after the vertical bar, because we have one line in our data set for every observations, and those observations are clustered by being the same person, the same ID. Group is not a sample of groups. It's not, we're not generalizing over groups. We want, so group, if we were going to put it in here, would be a variable over outside the parentheses to get the fixed effect. Or if we wanted to allow a random effect, we'd put it inside the parentheses, but in front of the vertical bar, which you will do in the next assignment, but not this assignment. Okay. Okay, so let me run both of these models. Now, why am I using REML? Anyone know? Did I tell you to use REML?
Sarah, we still see the whiteboard instead
Oh, you
of
still
the,
see the whiteboard?
yeah. Or I did at least.
Okay, do you see my R's now? Oh, okay, technology got me, okay. Why am I using REML?
Because it's the snow. We want the
It's
ICC.
the no model,
We want the ICC.
and we're gonna do an ICC on it, exactly. Okay, so I fit both of them. Now here I'm putting them.
Sarah, can I ask one more question about just the model setup?
Yes.
And maybe we talked about this before, but sometimes it's LME4, sometimes it's LMER. Does that make a difference here?
Right here?
Yeah.
Okay, yes and no. Okay, so both of these, so this one says LME4 lemur. LME4 is the original package by Bates, but Bates does not trust wald tests. So if you use the LME4 lemur function, you will not get wald tests in the summary of the model. If so, people have varying levels of mistrust of the wald tests, of the parameter estimates. Bates completely anti-wald tests. So his package LME4 does not give them. Some people said, well, yeah, we can't really trust them, but they can be helpful for getting kind of a gut check as you're going along. And we would like to have them even if they're not 100% reliable. Lemur test is a package that wraps, it's called a wrapper package. When we do lemur test, lemur, LMER, it basically does the LME4 lemur function and wraps it in such a way that it also gives you wald tests. So by and large, if you do lemur from the LME4 package or lemur from the lemur test package, you will get the same model. It's just whether or not it will also give you wald p-values. Does that answer the question?
Yes, thank you.
And it used to, this lemur test has not been around as long as the LME4. So some of my older code and older code you look at online will often use the LME4. I like to use the lemur test wrapper because then I can get those wald tests. But some of my old code doesn't have it, sometimes because I was lazy or not paying attention, or I was just copying something that I had on file from a long time ago. That's a great question. Any other questions? Okay, so here I put both of those models with the weak and with the obs in a tech reg table together. Now, what do we see about the intercept? Is the intercept identical in these two models? No, but it's fairly similar. Is the slope or the gamma, the parameter estimates for time, the same? It's not, because the units are different. In week, this would be how much someone's illness severity. So for week, this first model, this is how much someone's illness severity goes down each week if we model it as a linear trend, which, looking at the picture, should we do a linear trend so it's the same decrease every week? Probably not. We would probably want to put weeks squared in there to allow for that curvature. If we look at the next equation, time is treated as sequential number. Our beta, our gamma, our parameter estimate is now -68. So we could, this modeling says under the assumption of linear change, illness severity is going down by 0.32 units per week. Or we can say under the assumption of observation sequencing, illness severity is going down 0.68 units for each observation. Now, each observation is a different gap, right? 0 to 1 is a different gap from this baseline to the first follow-up versus the first to the second versus the second to the third. So it makes the interpretation sometimes a little bit more nuanced. Now, which way is better? Both of these are linear growth. It's just, did we treat the weeks as being the unequally spacing of calendar weeks or equally spacing them as in the number of observations? Oh, I got a double Q there. That's nice. Now, how do we decide which way is better? We looked at the pictures of the raw data visualization before, but looking at this table, how do you decide which one of those models fits the data better?
You can look at the AIC, BIC, the individual residual variance or the residual variance log likelihood.
Mm-hmm. So let's go over these. Now, AIC and BIC should not ever be looked at for a one model. They should be used to compare models fit on the same data set. Now, the TechReg is nice because it shows us this is the same data set, at least in the counts we can guarantee here. But okay, so AIC, the better model will have an AIC that is higher or lower? Lower. So according to AIC, which model is better? Unequal or equal? The equal has the lower AIC. Now this is under linear growth. We already saw in the plots, if we're going to do unequal times, we should have quadratic change over time. What about BIC? Which one has the better fit according to BIC? This equally spaced because it has a lower number for BIC. Log likelihood follows the same thing. Let's look at the very bottom of the table, the residual variance. What do you want your residual variance to be? Bigger or smaller? You want it to be smaller. So which model gives you smaller residual variance? The second model with the equally spacing. So if we're going to only use linear change, which one would be better to go with? Weak or OBS?
OBS.
OBS, thank you for saying it. I miss having everyone be able to chime in together. Okay, so here's your response. How do they compare? Which one do you prefer? Now, there is a note here. Are these models nested? No, because one's not totally contained in the other. One of these models adds weak, one adds OBS. One doesn't have everything that's in the other. So we cannot use the ANOVA command. What we can use, and I didn't put it in here, but you can use is the performance packages compare performance. Now I know we use this on another assignment. It's in the encyclopedia. We've seen it a little bit. You can ask it to compare the performance of non-nested models and rank which one is best. Oh, there we go. So I gave it two models. Since I said rank equals true, it has this yellow text at the bottom, but let's look at this. How does it compare these two models? It compares them based on AIC and BIC. We saw that. It also compares them on the R-squareds, a conditional ICC, this RMSE, this is the root mean squared error. It is the square root of the residual variance. So it's looking at residual variance, just the standard deviation instead of the variance. This BF is a Bayes factor, and then it computes an overall performance score. And down here at the bottom, it tells you in this sentence which model has better overall performance. And which model does it say is better? The OBS. Again, looking at AIC and BIC and this Bayes factor and the residual variance, the models don't have to be nested for these comparisons. They do have to be nested to do that log likelihood ANOVA chi-squared test. And then we can do the ICC. Now I want to talk, let's talk about the ICC first, and then I'm going to do long versus wide, because that was another thing. Okay, so in my screen, the way I have it set up is I have my, I'm going to clear it out, my console here. Oh, did you guys see what I just did? Did anyone see that? See, my console is blank. I like to clear my console every once in a while. It's the keystroke Control L. I don't know why, or Command L. If you do that, so here, like if I run some stuff, see how my console gets full? You can clear it out with Command or Control and the letter L. Kind of just handy. So I wanted to show you about the ICC, this last one down here, because ICC gives you two numbers, 2. So I'm going to come over to my console and I'm going to type question mark. Come on. ICC, question mark, ICC. And there are 2 packages that have ICC. The SJ Stats is the one I used to use. It says that it's depreciated. You can also say performance :ICC, and it will for sure bring you the performance package. But I want to show you what you can find in this help menu. You could also go to the help tab and in the little magnifying glass type ICC, or you can type performance :ICC. It'll bring up the same help page either way. Now it brought up a lot of them actually. I'm going to go back. Anyway, so you can get the help page. There we go. So every help page is written in a similar format, right? So at the top, it tells us the function and the package name, gives us a little description, usage, arguments, but I want to look at this details section here. This one gives you a lot of good help. What does ICC tell you? ICC tells you the proportion of variance that is explained by the grouping structure in the population. So it's telling us in this example, the proportion of variance in illness severity that is explained by person-to-person differences. The index always goes from 0 if grouping has no information to 1 if all the if observations in the group are identical. So if each person, every time we measured them, all 4 of their measurements were identical, our ICC would be 1. If repeated observations were not correlated, our ICC would be 0. Neither happen in real life. It's going to be somewhere in between 0 and 1. And that we can look at it as a proportion. Now, there are some really good other things down in here. So it talks about adjusted versus conditional ICCs. Because if we see over here in our notebook, it gave us both of those. Adjusted IC is 0.432 and conditional ICC is about 0.32. What's the difference between those two? And you can read this and find out. It says both ICCs take all sources of uncertainty in random effect into account. So both of these look at random sources of variability, while the adjusted ICC relates just to the random effects. The conditional ICC also takes the fixed effects into account. It's a really great reference, by the way. So this conditional ICC, this is how much the random effects explain, the proportion of variance of random effects explain. Now in our model, what random effects do we have? We look at our variance. What randoms? We always have residual variance. So what's the only other variance component we have?
Group to group variance.
Group, and in this case, it's person to person variance because we use that word ID, right? We did ID instead of group after the vertical bar. So nesting repeated observations into the person they come from, that accounts for 31% of the variance. So the interpretation here would be 32% of the variance in illness severity is due to person differences. Is that a lot? Is that not a lot? I don't know. I really don't care, right? Why do we have more than one person in the study? Because people are different, right? Do we care about Jill or Bob or John? Not particularly, but we want to be able to, we take multiple people so we can generalize out to more people, all similar people. So those people in our study are just stand-ins for all possible people. But this tells us that 32% of the differences, 32% of the variance in illness severity is due to person differences. Usually, we don't really care about that number, but we don't want to ignore it. It's kind of a nuisance. We don't want to ignore it. We want to take it into consideration. We want to control for person-to-person differences. So in this data set, 32% of the variance in illness severity is due to person-to-person differences, which we are going to account for, even though that's not like a research question. What about this adjusted ICC? It's bigger because it has not just the random effects, but also the fixed effects. If we come back up to our table, our random effect is just random intercepts for each person. What is our fixed effects?
Is it time?
It's time. In whether we're doing it as weeks or obs, it's time, passage of time. So 32% of the variance is due to person differences, but 43% of the variance is due to person differences and change over time. Now it's not in here, but I'm going to add another chunk, and I'm going to do slightly different here. I'm going to change this to, instead of ICC, to R2 for R squared. Okay. Now they're slightly different because, okay, we won't go there. We'll just worry about the ICCs. Okay. Now, I really appreciate this note that they put in here. So what kind of models do we run an ICC on?
The null model.
Null model, thank you, gold star for you. The null model. That's called the unconditional model. But they say usually, not always, but usually the ICC is calculated on the null or unconditional model, right? Usually. However, there's a caveat. According to Radenbush and Baroque, remember those are good names, you should sound familiar at this point, and some other smart people, it is also feasible to compute the ICC for the full models with covariates. That's called the conditional model, and compare how much level 2 variance is explained by the proportion of variance in the grouping structures, random intercepts. So this is why, and this bugged me for a while, if you do the performance compare thing right here, notice it gives you ICC for both models. Both of these models have time in them, whether time is a week number or observation number, we have an ICC for both of those models. Just a side note there. Okay. So question, is there significant trend in illness severity after baseline, after accounting for individual differences at baseline? Yes or no? Everyone thumbs up, yes, or thumbs down, no. Let's see them. Candace, yeah. Carly, yeah. Joey, which one is it? You're gonna go with the group? The group is right. How do you know this?
Because the estimate is statistically significant for the time variable.
So time, whether you make it week or obs, either way, the Wald test is significant. Now, the more appropriate way would be compare this to the model that doesn't have week or obs with the ANOVA command, but the Wald test gives you the same result here. But yes, because the parameter estimate for time, whether that's week or obs, either way, it gets 3 stars by the Wald test. Okay, other questions on the homework? Because let's get them cleared up, because you know the next homework is just this plus variables.
So in the phrasing of this question, I think I was just confused about baseline differences.
Okay.
Is that equivalent to random effects as we're talking about it in the model, or not quite?
Not quite. Now, did I do, let's see, I'm gonna add something in here. I'm gonna do this performance again, but did I have a model that was like 0, 0 that didn't have time in it? Oh, I thought I did. Yeah, well, I could do it. Okay, this is the idea of having conditional model. So and this is a question, is this really, let me show it here. Are these really null models?
Not necessarily, only because time, I mean, it seems like you're controlling for time. So maybe not a true null model, but
What would a true null model look like?
it wouldn't have any of the time predictor at all. Take out the time predictor.
What can I just take that out?
No, it's predicted by.
What if you just had a single intercept for
Group?
To be a true null model, we should have fixed intercept and random intercept like that, right?
Yeah, one.
With no time, not week, not obs, nothing for time. Okay, this is really great. This is so worth our time. Okay, I'm gonna add that one into here. So then I have to say, oh, I got a quote missing. There we go. Okay, so here is, I've added in a model that has nothing about time in it. Okay. Let me add this one in. I get this all to fit on my screen. There we go. Okay, so this one at the bottom is fit with nothing for time. What do you notice about its ICC?
Way low.
Compared to the other ones? It's lower. What about its R squared values? What's its marginal R squared? Nothing. But the conditional R squared is just grouping. The conditional R squared is the how much of the variance is explained by grouping. So if I do a performance ICC for that model that does not have any time in it, we would interpret this as about a quarter, because it's 24.1%, about a quarter of the variance in all the illness severity is due to person-to-person differences. Now, notice they're both the same, because are there any fixed factors in this model? No, we didn't add time. This is a purely null model. It's just fixed intercepts, random intercepts, that's all. This next model adds the fixed effect of time by putting in the variable OBS, observation number. Now we can say about 30% of the variance in baseline illness. Carly, you got like a Is the flashing really in your room, or is that just a computer issue?
I think maybe the light. I'm at my parents' house. I think the light's going out. I'll move rooms so it's not so distracting. Sorry.
Like, is that just me?
No, it's not. Sorry. I'll move.
Oh no. So oh, see, can I even type? Have you ever tried to type when someone's watching you type? Yeah. Okay, so a quarter or 24% of the variance of all illness severity is due to person-to-person differences. Since we've included OBS, this conditional is just for OBS equal to 0, which is baseline. So about 32% of the variance in baseline illness severity is due to person-to-person differences. Together, change over time and person-to-person differences account for about 43% of the variance in illness severity. Oh! So what's the ICC? Well, we got 3 different ICC numbers. We've got this ICC that's on the purely null model with no time in it. And then we've got the null model that has observation number in it. And so we end up with 3 different ICC numbers. This pure null model with no time tells you the percent of variance in all of the observations. This one down here that has OBS in it, the conditional ICC, is just for baseline measurements. And the adjusted combines that with change over time and the person-to-person variance amounts. Now, did I think you would get all 3 of those in there on your homework? No, but there's, some bonus. Okay. This is the extra complexity of having repeated measurements on the same person instead of just having a cross-sectional cluster of students in classes. Okay. Once again, we didn't take a break, man. And now we're to the point, do we just push through for 15 more minutes and have the break at the end? Egads. Somebody's got to be in charge of breaks because I suck at taking the break in the middle. Okay. Other things I want to talk about. Oh, yeah. Here we have the long version. What does the long version of the data set look like here? It has 1 line per
Observation.
Measurement occasion per observation. What does wide form of the data set look like? Here's wide form. It has 1 line per
person,
the level 2 units. Now, which one's better?
it depends.
Yay! Julie gets a star for today. It totally depends. So here is kind of a breakdown. Long form has to be used to do those plots where you connect the dots, or the spaghetti plots or the mean plots. You need to have long form to do the plots, and you need to have long form to do the lemur model, the multi-level model. You have to have long form for modeling and plotting. So what in the heck can we use the wide form for? Anyone notice? It's useful for demographic summaries, so your sample size is the number of people. The wide form is good for pretty much all of those table ones. It's also good for looking at attrition, and it's also mandatory for looking at correlation or covariance between repeated observations. So Often you will want your data set not just in long, not just in wide, but both. And here is a command, pivot wider, and there's another one, pivot longer, for going the opposite way, from wide to long, long to wide. We're not going to take a bunch of class time to do this, but for your course project, guess what you're probably going to have to do? Take it from one format to the other. Whichever one you have, you'll probably want the other one too. This is something I can help you with. Okay, because it takes a while to get used to this. Every software, every statistical software can do this in its own way. R has about 70 different ways to do this. I like the pivot functions, but I can help you because it takes a long time to kind of get used to them. And I wanted to hit that. Yeah, see, so when I'm making this table one, I use the wide format so that I get these the different time points are different variables. Okay, somebody had something on the discussion board about correlation versus covariance. Can someone summarize what that comment was about? Anyone want to go out on a limb? Was it you? Was it someone you read? I don't want to call anyone out. What's the difference between correlation and covariance? They're not the same.
That was my question.
Yeah, Mike asked the question. Does anyone else have the question? What's the difference between covariance and correlation? Did you think they were the same? They're similar. Okay, correlation. Usually when we say correlation, we mean Pearson's product moment correlation. It is always between what number and what number?
-1 or
0
positive.
and 1, positive or negative. So yeah, -1 to +1, Mike. Yeah. So correlation is nice because you always know what scale it's going to be on. You know what's strong correlation versus weak versus moderate. Covariance depends on the scaling units. So there's not a max and a min. 0 covariance means 0 correlation, but it's not a max number. Positive and negative are the same way for covariance and correlation, but the actual number depends on the scale of the thing you're measuring. So this covariance, when you say COV, you get the variance covariance matrix, and we call it the variance covariance matrix for a reason. I want to look at the COR does the correlation matrix. I want to point out what's on the diagonal of every correlation matrix. 1, because every variable is perfectly correlated with itself. But when you use the COV command, what's on the diagonal? Not 1. These are the variances. So 0.75 is the variance of, and if we look to the side, it says 0, and above it says 0. So this is the illness severity at baseline. The variance is 0.75. At time point 1, the variance is like almost double. It's 1.51. If we go up to the third time point, what's the variance? It's even bigger. Do we have homogeny of variance? No. Should we be doing an ANOVA? Heck no, because we're going to violate the assumption of homogeny of variance. If you did Levine's test, it would just, boom, 3 stars, you were violating. So on the diagonal are the variances. Now, what does a variance of 1.5 mean? What does the number 1.5 mean? Depends what the units are, right? It's 1.5 illness severity points. Covariance is the same type of thing. The size of the number depends on whatever the units are for the thing you're measuring. We're measuring illness severity here with the IMPS 79 items. What is nice about this is it's unit specific. Looking at patterns, it's a little bit rougher because the units don't have that natural max of 1, +1 or -1. That's why when we usually make the correlation plot to look at it. Now, what do we see about time points that are close together? Time points that are close together are more strongly correlated, see, between baseline and 1 week, 1 week to 3 weeks, 3 weeks to 6 weeks, right here, right off, just barely off the diagonal, they're pretty strong. What happens if we go further away from the diagonal? This farthest away point. This is between baseline and week 6. What about the size of that correlation? It's smaller. Now, here's another thing. If we were to analyze this data with repeated measures ANOVA, not only would it assume that we had equal variance at each time point, it would assume that we have equal covariance or equal correlation. It would assume that all of these correlations are identical. That's the sphericity assumption. Are they all identical? Are they close? Not really. I mean, here, this one's out here is 0.15, but some of these on the diagonal are 0.67. The average of all those correlations is the ICC. So down here, so that's another way you can think of this. So you can also think of this. So this is the correlation the ICC ran on the truly no model with no time in it. So this is, so we could think of it, the average correlation between repeated measurements made on the same subject is about R equals 0.24. Now this correlation, ICC down here, this is if you take into consideration the timing or the sequencing, because we have the variable OBS in this model. So this is the average correlation if you weight based on how far apart measurements are. So closer measurements are more strongly correlated than further apart measurements. So that's another way that the ICC ties into the idea of correlation. That's why we use rho to mean the ICC. Rho, that Greek symbol, is also used to represent correlation in other scenarios. I think there was one more point that we needed to cover on the homework, and it's not on my list. Was there something else?
Oh, I wanted to say, you know that graph with the bubbles? Will you go back to that graph with the bubbles?
The core plot.
I just want to kind of do a shout out because I never really understood that thing at all. And Carly on our last session described this thing perfectly about how you can see the sphericity assumption being broken, and it made sense. I was like, man, she could just teach it. So I guess I wanted to just say thanks.
Here's one thing, you guys, after taking this class, when you graduate, you all can teach this class. You might be called on if you go into academia teaching this, or a workshop explaining it to someone else. You now know more about this stuff than 99% of faculty. Is that scary? Yeah. You guys do great, though. I don't have any concerns. You guys are great. Okay, yes, but the core plot, measuring, yeah, you can see here the violation of the sphericity assumption, because all of these circles are different strengths. Now I changed it to upper equals ellipse because I like to have them ellipses instead of just circles. It helps me see the tightness of the correlation. Besides the color saturation, the shape changes. Yeah. Okay. We only have 10 minutes and we didn't take a break. I don't really feel like starting something new. What other questions do you guys have? Keep me talking so I don't have to start something new.
Can we have some more time to go over our assignment?
Yeah, what do you want to go over?
No, I don't mean in class, I mean before we turn it in.
Oh, it's due tonight at 8. You want more? Okay. How much?
I think he's saying you can let us go early and then we'll have a little bit more time.
Oh, let you just, okay. Or I thought, Michael, do you want the deadline extended?
That's what I was asking for, yeah.
Yeah, oh, okay. When do you want it extended to?
Just depends on how much sleep I'm gonna get tonight, but I can do it tonight.
Tomorrow at 5?
In the morning?
Heaven's sakes, no.
No, I get up at 5.
Oh, I don't.
Um,
I'm not going to be grading it before 5 tomorrow. In fact, I won't grade it before 8 tomorrow.
no, I seriously, if we could turn it in tomorrow, that'd be great. Because I do get up at 5 and do this kind of work. It's easier in the morning.
Let's give you an extra 24 hours till 8 o'clock tomorrow night. How's that?
Oh, that's
I
great.
know a lot of you turned it in. I'm sorry. If you want to return it in, you can. If you upload it again, I won't see your old one. I'll only see your most recent upload. If you want to go tinker with it. And consequently, I will promise to have the next homework assignment out to you by 8 p.m. tomorrow. I want to have it out by 8 p.m. tonight, but I don't know how for sure that'll happen because it depends on Amanda's defense tomorrow. So I better get it done tonight. Okay.
Thank you.
Okay, so let's call it a wrap on today. Unless you want to stick around and ask questions about homework or setting up appointments to meet with me about your course project. How about we have that opportunity right now as well for those that need it. I'll pull up my calendar. Okay, so I'll keep the recording going till we're done, but you're free to go.
Thank you.
Hey.
Looking through the questions that are on the thing that's set up as a quiz for our project, it seems to me that, I mean, please correct me if I'm wrong, but it seems to me that it might be, if we haven't had our appointment with you yet, I do have the appointment reserved, but it seems like that would be a good exercise to go through before meeting with you. Just to have.
Some people aren't sure though, so it depends on your level of concreteness in your current project. Like some people wanted to have a brainstorming session first. So, you know, if you know what you're doing, yeah, do it now. If you need to have a brainstorming session first, wait.
Okay. Thank you.
Okay, so let's see. Allison, Chung-Soo, Jill, Michael, who needs an appointment set up? Jill and Chung-Soo. Okay. Chung-Soo, you sent me an email. I just saw it pop up. Is that what this is? The email was about the appointment? Okay. Here's my calendar. Tomorrow I am booked. And Thursday I'm probably going to reschedule the workshop from last Thursday because last Thursday I had to cancel class and the workshop both. So how about next week? And no docking points because obviously it's my scheduling issue. Here is my schedule. So anything that says Stat Studio is open on the appointment manager. And if there's nothing there, it's also open.
So I prefer having a meeting on Tuesday morning.
Tuesday morning? Okay. Tuesday morning on the appointment manager, 9:30 and 10:30 are open. And those you can book through the appointment manager. Do you have the link for that?
No.
Okay. Let me send it to you. I will just reply to your email. Okay. If I reply to an email right there says Stat Studio Appointment Manager book here.
Oh, okay. I will do that.
So I'll send that to you. And then you can, so when you click on that link here, I'll show it here. In case, Jill, in case Tuesday morning works for you. Let's see.
Oh, I'm good actually.
Oh, you don't need an appointment?
Well, so that's what I was about to say, is that I'm on your schedule.
You're on the schedule?
I'm on your schedule with my advisor on Wednesday.
On Wednesday. Where's my mouse?
Of course, it has neither of my correct names. It's Ashby Melissa. Not this Wednesday, next Wednesday.
Next Wednesday. Yeah. Okay.
Keep meaning to get my name changed through the school, but then I might have to tell them I moved out of state. I'm not taking risks on tuition changes.
I think right now that's more with grad students, that is so common about not in Cache Valley right now.
Right. Well, in like other schools, they have like a dissertation, like a thing where you just apply and tell them like, and then you can get in-state tuition if you've had it already. And it's just like a thing they do. But Utah State, it's just like everyone I've talked to is just like, shh.
Yeah, just don't bring it up. Yeah. Changsu, were you able to get that figured out?
Yes, yes. And I have two questions about the assignment. Can I ask you? First question is, I understand why.
I'm gonna go.
Okay, bye, Jill.
I understand why group variable, like a treatment or control, used as a predictor. But I'm really confused when 2 weeks ago we learned the 3-level analysis, and we used the two, like I remember the word and hospital used as a group variable, and we put those variables aside the hyphen. So I really confused with these two concepts. Why?
Right here. It goes back to, right, yeah, so this is the nurse. We have one line in our data set for each nurse, and then nurses belong to a ward, and then the wards were in a hospital. The reason this one was 3 levels is it was a 3-level stratified sample. The way that they got the nurses is first they selected hospitals, and then after they had the hospitals, they selected some of the wards in the hospital. And then in each ward, they selected some of the nurses. So there's 3 levels of sampling. Now, so like the example we did today, there's only 2 levels of sampling. The group was, there were only 2 groups that and the group applied to the person. We didn't, and if we only had 2 hospitals, hospital would be a fixed effect. But to units of a level, it has to be a sample that we're going to generalize over, not a listing of all possible options we care about.
So you mean it is related to some sampling issues, right? Because the group variable acts as just a treatment, not a generalized sample, right?
Yeah, we don't want to generalize over all treatments possible. You want these 2 or 3, whatever treatments. Here we wanted to generalize over nurses, generalize over wards, and generalize over hospitals. Because we had a good number of hospitals and a good number of wards and a good number of nurses. And none of them, like, and I think in this example, there were 2 types of wards. They were either specialty or normal wards.
In that case, we cannot use the group variable in the model, right?
That was ward type. They were either a regular ward or a special treatment or special care ward. So that ward type is a variable that applies to the ward, but those are the only 2 types we care about. We're not generally more types of wards.
And the other question is comparing the model when we use the AIC and BIC when the model is not nested. But I was wondering how to compare these values when and in a way of statistical ways.
You cannot get a p-value when comparing BIC. And so if you want to get like a p-value to statistically test, you have to do that likelihood ratio or deviance difference test with the ANOVA command that uses the chi-square distribution. AIC and BIC are both equal to the deviance plus that has been penalized, and they penalize in different ways. AIC is less strict penalization, BIC is more strict. So if you were to take the log likelihood and times it by -2, then it becomes the deviance. So in this table right here, so if I double this, that'd be like, where's a calculator? I can't do that in my head.
So when we compare the model using likelihood, we use the chi-square test, right? Degree freedom compared to the okay.
So we've used the ANOVA command in R, and it lists down here the AIC and BIC. But here's the log likelihood. If you take the log likelihood and times it by -2, it's the deviance. Now, if you notice in the model, the deviance is 1942. If you apply different penalties, you get the AIC and BIC. The AIC penalizes it a little bit. The BIC penalizes it more. It makes it a bigger number. So AIC and BIC, you can compare them to see which one's smaller or bigger, but there's not really a cutoff.
Mhm.
The deviance, you can subtract them, and that's the chi-squared value when the degrees of freedom are the difference between how many parameters. So this one had 4 parameters, this one has 11 parameters. 11 take away 4, 7. So you can do a chi-squared test to get an actual p-value for the likelihood ratio or deviance difference test. But AIC and BIC, you can just compare big or smaller. But you can do AIC, BIC comparisons for non-nested. The likelihood ratio deviance difference chi-squared test has to be nested models.
And the last question is related to my project, and I revisit my data, and there is a 3 dependent variable. That means I have to use the multivariate approaches in doing modeling. So, and before doing the assignment, I searched some articles about how to do the multi-level multivariate multi-level modeling. Yes,
Yeah, so I read through what you put on here. And so you said a 3-level model, but I think, yes, you have 5 time points for each subject, but the intervention, instead of being a 3rd level, should be a fixed factor that applies to this subject, because this intervention was randomized or repeated on subject. We don't want to, it's either part, task, or whole task. Those are the only 2 we care about. So this should not be a 3rd level. It should be a fixed factor. So that's what I wrote in here. I think intervention should be a fixed factor that applies to the subject, not a 3rd level.
okay, I see.
Yeah, and so, and then you have the complication that at each observation, you actually have multiple scores at each point. That's the multivariate component, right?
Yeah.
And so
I searched some articles, but yes.
Yep, so I was trying to find them. So I said, I want to talk to you about this some more. And I pulled these out, but I haven't had a chance to read the articles in their entirety. But I think for the project, you might want to start by only looking at one of the outcomes, one at a time, and then combining them into the multivariate, multi-level model. So let's see, what are the 2 outcomes? And I get that you're frustrated. This is the most complicated part, is when you try to explain. Let's see, where is it?
Yes.
So you've got cognitive load that's a continuous, and then the learning outcomes. Yeah, so you've got these multiple outcomes. I would say do each dependent variable one at a time to get started. And I will start teasing this apart. And after you model, so I would do just, now cognitive load, that's the type of.
The research question 1 is the effect of the treatment on the cognitive load, but the cognitive load consists of 3 different constructs, and so
yeah, so
means
the easiest way is to do each of the 3 constructs one at a time. So first do extraneous and do that one first, ignoring the other 2, and then do intrinsic, ignoring the other 2. And then this germane, ignoring the other 2. So that would be the univariate multi-level modeling. I would suggest for the project that you do that first. The way we usually handle the multivariate approach with mixed effects regression is the domain becomes the lowest level. So let me see, let me share. New share. Let me share the whiteboard again. Okay, let me clear this. Okay, where'd I put my pen? Okay, so we'd say on each person, we have, there's 5 time points.
Yes.
and 3 constructs.
Yes.
So they would have 15 dot, dot, dot. I'm not going to draw them all, right? So these would be at time 1. These would be at time 2. Actually, there'd only be 3 of them. Like that. And so this would be, let's see, extraneous, intrinsic, and germane. So sometimes we call this, there's multiple ways to handle this. And it depends on a lot of other stuff, which way's the best way to do it. So let me see, let me erase all this for a minute. Okay, so one way would be to do it. We have extraneous, intrinsic. Well, no, because that's a
Germane.
I think you would want to do 1, 2, 3, 4, 5. So you've got the time points. 0, 1, 2, 3, 4, and you've got person. Oh, and then dot, dot, dot. Let's call this one 5. And I'm gonna, oh, but if I'm gonna number it that way, yeah. 2, 3, 4. 1, 2, 3, 1, 2, 3, 1, 3, 1, 2, 3. And so here's the actual score. So you have 15 scores per person. So this would be level 1. Level 1 is made up of the individual scores, which you have n equals 15 per person. Level 2 would be the time points, which you have 5 per person. And then level 3 would be the person, which you have n is the number of persons. So this is one way to do it. This, you could do it as the 3-level model. Now, the other way to do it is called a cross-classification model. And it's handled in, let's see, which chapter is it? Chapter 9. Yeah, it's a cross-classification. Let's see, let me look, 165. Let me see if they have a component in this one. Okay. So this is one that I've done before. I think this is the most, this 3-level is the most common way. Let's see, in chapter 10 is the multivariate multi-level regression. Yeah.
I picked very complicated model for this project.
So that's why I said for your project, I would be okay if you only want to just model extraneous as one analysis, and then intrinsic as another one, and then germane as another one, and keep them as 3 separate models for the course project. Now for a publication or dissertation, you would probably have to go a step further and do this multivariate one. But that's something that's a little beyond. So in chapter 10 is where it's the multivariate multi-level regression akin to MANOVA. So that's what this pretty much is.
Honestly, I read this chapter before this class. But I don't understand what the Hawk said, and there's a lot of annotations. So that's why I searched the other articles and find the R or N plus code.
I think that, let's see, let me go back to that. If I can't remember, let me see, let me pull up one of those articles. And pulled them up the other day when I was reading what you'd submitted. So this one, multiple outcomes in clinical research, multivariate, multi-level models. So one of the problems is multivariate, multi-level models can mean mixed effects models that we're learning in this class. It can be done with SEM, structural equation modeling. And they should get largely the same answer, but this multivariate, multi-level modeling doesn't tell me which one they're doing. So, let's see, I get the full article. I'm not going to, let's see. Oh yeah, here's the supplemental. Yeah, I think that I did look at the supplemental here. Let's see, it's opening it in Word.
I executed the R code, but it didn't work. But M plus does work.
Yeah, so they do it Stata, SAS, SPSS, and R. So long data set, wide data set, SAS is probably what is proc mixed. Yeah. That's the first way I learned how to use multi-level modeling. And then in SPSS, that's the second way. They'd use the random and repeated statement in mixed. So this has the random, this is the random slopes and intercepts, and the repeated has additional variance structure, which is the other article you're supposed to read for class next time is on covariance structures. So taking this class is exactly for this data analysis, yeah. And then in R, so they're using MC, GLMM. They're not using lemur like we are in class R. And this is the reason, it's just another way to solve them. So I was looking at this, and so here you bind the different outcomes together, and then they have no intercepts. And I remember reading this. They said they didn't want any intercepts because they wished suppress the overall intercepts so that they could get fixed effects of the dummy coding of trait. And instead of doing trait asterisk TX asterisk time, they used the colons so that they didn't include that intercept. So they're manually saying, I want this 3-level interaction and just 2 of the two-way interactions. So they're purposely excluding the TX by time interaction, and they're not having a TX or a time main effect. And then when you use this command, so usually when we've been doing it after the tilde, you have the fixed effects, and then in parentheses, you say the random effects. In this function, you have to say the random effects on another line. And I haven't used this package before, so I'm not I'm not exactly sure what it's doing here. This is saying that it's treating both the outcomes as a normally distributed. And this burn in and the number of iterations, and then the prior distribution. So this is using kind of a Bayesian method. Yes. Oh, there it is. It says Bayesian because they're inputting this prior distribution into it. Now you have to have some information why you would choose this prior distribution. You can't just make it up. And this is not something that I've done a lot of. So they say right here, the 2 primary multi-level modeling packages, NLME and LME4, those are the ones we're using, cannot fit this particular model because they do not allow for the residuals to take the form described in equation 10. So that's why they're going through this other Bayesian method, the MCMC-GLM package. So they can do this Bayesian, but again, they have to have this prior distribution specification. Yeah. So I would say for the project, why don't you just first analyze those dependent variables one at a time? And that's plenty for the course project. If you want to then keep going to this multivariate method, I would say the first thing I would try to do is do it as the 3-level model. And that's assuming some things about the distribution of the residuals, and the residual diagnostics will probably look really poor. And at that point, then you'll need to move probably over to something like this. But that's way beyond the scope of what I want you to do for the course project. Now, I'm happy to help with it. I just wouldn't bite that off for the course project.
Do I have to change the topic of the project because I cannot cover this? Yes, because
No.
I have another data set from my advisor, and she already consulted this data with you.
Who was it? You know, or when was it?
I didn't remember when she did, but it's a game data, and you already analyzed, but the time effect did not work. Her name is Gina, Korean person.
Gina, let's see.
But
oh, and let's see. Gina, is it J-I-N-A?
Yep.
What I thought. Oh, come on. Okay, let me come over here. Yeah.
Yes.
Okay, here it was. So it was, oh, it's probably this one. Was it?
We can finish the recording.
Oh, yeah. We should stop the recording. Thanks.